We want to find the area of a triangle when all we're given is the points of that, vertices of that triangle on an xy plane. So the points are -2, 2, 1, 3, and 3, 0. So we could plot this out, but we're still going to have to use a formula to find the area of this triangle. So the best way to do it is to just skip plotting it and just see what the formula is and then go from there. To find that, what we need to do is find the determinant of the following matrix. So that matrix is area of a triangle is equal to 1/2, and then we say A, B, 1, C, D, 1, and E, F, 1. Now these A and B's, C and D, and E and F correspond to these ordered pairs. So this is the first point, this is the second point, this is the third point. And it doesn't really matter which order you put the points in, just as long as you use the rows as the individual points, not the columns. So we need to plug these values in and then find the determinant of this third order matrix. So if we plug those in, then we get area equals 1/2, -2, 2, 1, 1, 3, 1, and 3, 0, 1. Great. So now we can find the determinant of this, and that's what our final answer is going to be for the area. So from the area matrix, to find the determinant, what we say is we have area equals 1/2, and then we need to have a big bracket where we're going to have 3 second order determinants. So the first one is going to be this value times the determinant of this matrix, and then the second one is going to be this minus this rather times the determinant of this, and then the third one will be this value times the determinant of this. So let's write that out and you can see what I mean. So to begin with, we have -2 determinant, and then what we have here, 3, 1, 0, 1, minus this value, so this is a minus, the other ones are just the normal values, minus 2, and then determinant of what we have here and here. So that's 1 and 3, and 1 and 1. And then finally plus what we have here, so plus 1, times this determinant, what we have here. So that's 1, 3, and 3, 0. So then we need to figure out what each of these is in turn, and then we can actually finally solve this arithmetically. So this becomes -2 times this minus this times this. And that's the same method that we're going to use for each of these determinants of the second order determinant. So this times this minus this times this. So 3 times 1 minus 0 times 1. So -2, now we have 1 times 1 minus 3 times 1 minus 3. Finally, 1 times 0, which is 0, minus 3 times 3, which is 9. So we finally got this down into a normal arithmetic sum that we need to expand a little bit and solve for. But that will give us, in fact, the area of this triangle. So let's simplify this a little bit, and then we'll finally get our answer. So now we have the area as 1/2 times what we have left here. So 3 minus 0 is just 3, times -2 is -6. Here we have -2 times -2, which is +4. And here we have just -9. Then if we work this out, we get 9 minus 6, which is -15, plus 4, which is -11, and finally A equals 1/2 times -11, which is, let's write it here, A is equal to -5.5 square units. Now we really need to think about this. We have an area that's a negative number. So this was perhaps a little bit confusing to get to this point with these 3 determinants, but then when we solved it arithmetically, we didn't make any mistakes, but we have a negative value for the area. However, it's okay because the area can be given as a negative when we use this method. You just have to make sure at this point to take the absolute value. So it doesn't make sense to have a negative square value of units. So you have to just take the absolute value, and we'll say finally that the area is equal to 5.5 square units. And that's how you do it given 3 points.